Suppose we want to calculate the square of a number and print the result in a formatted way. We can write a function like this. It mainly does two things, calculation and printing. For example, when we pass in the number 3, the output will look like this. This is a very simple function. But what if we want to extend it? For example, to print not only squares, but also cubes. All-in possible solution is to pass in an extra parameter indicating the power, 2 for square, 3 for cube. Now another problem arises. What if we also want to print the result of adding 10 to the number? At this point, it may feel hard to proceed. No matter how you change the logic, it starts to look messy. From another perspective, the reason this feels awkward is that we've kept the calculation logic tightly coupled inside this function. But what if we pass the calculation itself as a parameter? In that case, we can first define separate functions for squaring, cubing, and adding 10. Inside the calculation and printing function, we simply call the passed-in function to get the result and then print it. What that function actually does, whether it calculates a square, a cube, or adds 10, is not the concern of this function. When calling it, if we want to calculate and print the square, we pass in the square function. If we want to calculate and print the result of adding 10, we pass in the corresponding function instead. Yes, functions can be passed into other functions. A function that takes another function as a parameter is called a higher-order function. One important thing to note is that when passing a function as a parameter, you pass the function name itself without parentheses or arguments. Once you add parentheses, the function gets executed, and what you pass in is its return value, not the function itself. After switching to a higher-order function, the overall logic looks like this. This approach is easy to extend. For example, if we often need to calculate and print the result of multiplying by 5, we can simply define another function and pass it in when needed. We can even pass a formatting function as a parameter, allowing us to support different output formats without changing the calculate t and $print function itself. In summary, higher-order functions provide much more flexibility in our programs. A real-world analogy would be a multi-purpose hairstyling device. The main unit handles airflow, temperature, and speed, while different attachments, like curling barrels or nozzles, enable different functions using the same base. The higher-order function is like the main unit, and the functions passed in as parameters are like the attachments. Sometimes, however, the function we pass into a higher-order function is only used once, and giving it a name and defining it separately can feel a bit excessive. Anonymous functions are well suited for situations like this. As the name suggests, anonymous functions don't require a name and are often used as one-off, disposable function. If we must refer to them by name, we usually call them lambdas, since they are defined using the lambda keyword. We can define a lambda function directly inside the call to a higher-order function, starting with a lambda keyword, followed by parameter names and a colon. The variables before the colon represent the parameters passed into the anonymous function. After the colon, we don't need to write return. We simply place the expression whose value will be returned. To add more parameters, we just list them after the lambda keyword, separated by commas. You can think of an anonymous function as a function without a name that takes up fewer lines of code. For example, if we rewrote this anonymous function as a regular function, it would look like this. As you can see, anonymous functions reduce the number of lines, avoid naming, and don't require indentation, making them ideal for one-time use cases. Besides being used as arguments to higher-order functions, anonymous functions can also be defined and called directly. Just like regular functions, the only difference is that the lambda expression itself must be wrapped in parentheses to be treated as a single unit. However, anonymous functions have limitations. They can only contain a single expression, so they are suitable only for simple cases. For complex, multi-step logic or scenarios involving loops or recursion, lambda functions are usually not flexible enough. Even if such logic can be written using a lambda, readability often suffers, so in those cases defining a regular function is the better choice. See you in the next video.